Hi, my name's Stuart Lynch, and this is the second video in the WatchKit section of the 7-part MyTallies app. And in this video, we're going to be implementing WatchConnectivity, and we're going to be transferring all of the tallies from the iPhone app to the watch on first launch. And then after that, any change made on either the watch or the iPhone will be sent as a payload to update the companion app on the other side. I love getting your feedback, so if you enjoyed this video, please give it a thumbs up and leave me a comment below. Make sure you ring the bell to enable notifications and get notified whenever a new video is released. And if you want to support my work, you can buy me a coffee. A link is in the description. If you're following along with this series, you can continue on from there, as I'm doing here. But if you skip those first 5 videos, you can download the completed source code from the last video from the link in the description. There are several branches on the Git repository, so make sure that you download the WatchKit 1 branch, as that's the completed source code from that 5th video. The WatchKit 2 branch contains the completed source code for this video and will also serve as the starter source code for the next video. You can just download and expand the zipped archive. The project requires Xcode 16 or later. In the last video in this series, we began work on our watch app target. We were able to verify a connection between our iOS app target and the watch OS target, and then we designed the interface for our watch app using a model that closely resembles our iOS Swift data model, except that it's called WatchTally, and it's managed by a Tally Manager observable class that'll keep the array of tallies and the selected tally in memory. But what we want to do the first time our iOS app launches is to send over the watch app's payload of data that will be an array of these new WatchTally items, and then we'll be able to construct the array because we made WatchTally a member of both the iOS and watchOS targets. Well, in order to do this transfer, we have to implement some new functions in our connectivity class that'll take an encoded version of the array and send it as a payload to the watch app, and then when the watch app receives the payload, it has to decode it and update the array in the Tally Manager with that payload's array. Now, since our Tally Manager class is observable, the array of tallies will get updated in our watch app. So when transferring data between an iOS app and a watchOS app, there are a few ways to send a payload, and that's a dictionary. And the WatchConnectivity framework is the key API for this, and it provides multiple methods for transferring data. And each method is suitable for different use cases depending on factors such as whether the watch app is in the foreground, the background, or not running. And the immediacy or persistence of the data you are sending is important. And the 3 methods are send message, which sends an immediate message from iOS to watchOS or vice versa, and optionally waits for a response. But if the app's not running or the watch is not reachable, the message is discarded. And then there's transfer user info, and that data is queued and delivered reliably when the other device becomes reachable, even if the app is not active when the data is sent. The problem I have with this, though, is that it doesn't work in simulators, only with real devices. And that would be really difficult for me to demonstrate in a video to show that interaction between the 2 devices. Well, there is also transfer file, but that's more suitable for large files like media files. So what I've settled on is the update application context, because it sends the most recent data to the counterpart app, and it overwrites the previous data sent using this method, so only the latest data is kept. If the receiving app isn't reachable, it will get the latest context when it becomes reachable again. Now, it's best for keeping both devices in sync with the latest app state. Now, the payload that gets sent is a dictionary in the form of string any, where that key will let the recipient know what to expect, and the value can be our data, which is going to be our encoded array of WatchTally. In our iOS connectivity class, I want to create a method called setContext, and it's going to have a single argument, and it will be payload, and that will be a string any dictionary. So first, we'll create a session, which is a WC session default. And then we check to see if the session's activity state is equal to activated. And if it is, then we can call the session's update application context function, passing in that payload, but this may throw an error, so we'll have to enclose it in a do catch block. So for now, I'm just going to print out an alert, but you may wish to handle this by presenting an alert to your users in the future. What we need to do now then is create a method that we can call from within our iOS app that will build that data dictionary to be sent over when that app becomes active. Well, we can call this send updated tallies, and we'll pass in the current array of the Swift data array of tally. Then we can create the array of WatchTallies by taking the tallies array and mapping that tally to the corresponding WatchTally using the corresponding name and value. And then we can use an if-let to form our JSON data by trying to use a JSON encoder to encode the WatchTallies. If this is successful, then the tallies dictionary is ready to send over. So we can use a key like tallies, and for the value, that will be the JSON data. And then we can call that set context function we just created by setting the payload to our tallies payload. Now, to ensure that we have a successful transfer of the payload, in the tally selection view, whenever our scene phase changes to be active, we can call the connectivity function, sending in the array of tallies. Now that's sending it from the iOS end. On the watch end, we need to go to the watchOS connectivity class. And here, we're going to have to create some kind of a function that can respond to receiving that payload. And that is the didReceive application context. And that will receive the payload sent from the iPhone as the variable application context. And that's that payload dictionary. Well, we'll be updating the UI, so we'll need to make sure that it is executed on the main thread. So I'm going to create a task unit of work and apply the main actor. Then I can let the Tally Manager be an instance of my shared Tally Manager class. And then we can use an if-let to assign to a WatchTallies data variable if the application context has a key of tallies, and we can typecast it as data. If it is, then we can use another if-let to determine the decoded tallies by trying to use a JSON decoder to decode the array of WatchTally types from the WatchTallies data. And then we can set the Tally Manager's tallies array to the decoded tallies. And then we can make the Tally Manager's selected tally the first one in that array. Now, if it fails, I'm just going to print out an error message to the console. So we can test this out now between our two simulators. So first, we'll run the Watch app. So we have to make sure that the Watch app is selected and run that. And after it launches, we can then run the iPhone app. And we make sure that we do have that connectivity, which I see we do. When it launches and the first view appears, it sends the payload over and our Watch app decodes it. And you can see if we go to the list view, all of our tallies have been transferred over. The data will be maintained in the app as long as it's in memory. So we can go on to another app and come back and the tallies will still be there. The only time we need to send over this entire payload will be when our original array changes. And that happens on the iPhone whenever we add or delete a tally. So if we update, then we'll be sending over the updates. So let's go back to the iOS target. And we'll need to call that connectivity function every time we add or delete. So when we add, we presented that modal sheet. So why don't we add an onDismiss argument? And then that within the argument's action, then we will then apply the connectivity's send update tallies, passing in that now updated tallies array. And then the deletion happens within the action of that trash toolbar button. So we can call that same function in the action there, right after we delete the tally. So let's test this out once more again by making sure we're running the Watch app first. And then once it's loaded, we'll run the iOS app to get that initial array sent over and set the first one as the selected one. So let's test this out on the iPhone app by creating a new tally now. And if I go over to the Watch app, I can see that that new tally shows up in the list on the Watch app. So let me return back to the iOS app now then and delete that newly created tally. And great, it's been deleted from the Watch too. So the next step then is to send updates both ways to update the corresponding value for our tallies. When we tap on a tally, either on the phone or on the watch, we want to be able to transfer just that tally and its updated value to the watch. So this is going to be a very similar process to what we did initially. So let's start from the iPhone. In the iOS connectivity class, I'm going to create a new function called update selected tally. And it's going to have a single parameter that will be a selected tally that's an optional tally. Well, then we can use an if-let to unwrap it, and then create a watch tally object using the selected tally name and value for that watch tally. And then we can use an if-let to create payload data by trying to use a JSON encoder to encode that watch tally. And then we can create an update payload constant that's a dictionary of type string any by specifying this time that the key is the string update and our value is that payload data. And then we can call that same setContext function, but this time we'll send the update payload. Well, this function is going to need to be called every time we update our tally on the phone. And this can happen when we tap on the tally or when our app and the widget had performed an update or through a shortcut. So in the tally selection view, this happens when we reset the tally. So let's add that here. Now I'm back in my single tally view, and to be honest, I think I made a bad design decision here, as we have this on tap gesture being used here in this view, and we're also sharing this with WidgetKit, where we can't use the connectivity class. So I'm going to cut out this tap gesture from here, and I'm going to move it to the parent view itself. So back in the tally selection view, I'll add that to our single tally view, but I'm going to need to rename the tally as selected tally and force unwrap it. And then in each of the two cases, we can call that connectivity update selected tally by passing in the selected tally. In our Siri shortcut, where we update our name tally, we'll need to call this function here as well in the update tally function. So in the function, we get a shared instance of the connectivity class. And then we can send the update after we save it. So that's going to send the updates from the iPhone. Let's go back to the watchOS connectivity class where we can accept it. And that's again in the didReceive application context function. Well, now we can receive a payload dictionary where the key is not tallies, but update. So we can use an else clause here. First, we check with an if-let to unwrap the updated tally. And if it's an application context dictionary value with the key update, we can typecast it as data. Then another iflet to create the decoded update by trying to use a JSON decoder to decode a watch tally type, not an array, from the updated tally data. Well, then we can find the index of that tally in the Tally Manager's complete tallies array by finding the first index where the iterator's name is equal to the decoded update name. Because remember, name is unique. And then we can access the tallies array from Tally Managers at that index value and update it with the decoded updates value. Now, this might not be the one currently selected, so we'll need to check to see if the Tally Manager's selected tally name is equal to the one being updated. And then if so, we can create an animation block and update the Tally Manager's selected tally value with the decoded update value. We'll need to import SwiftUI for that animation block. So time to test. Again, as per usual, we'll start by running on the watch first to get it loaded. Then we'll run on the iPhone and it'll pass the entire array over. But on the iPhone, that selected tally is alpha. I'm going to update it. Perfect. It updated the watch too. Let me reset. Good. Well, let me exit to the home screen and use Siri to update alpha. Update alpha with MyTallies.
Updated alpha to 2.
Let me use the Siri picker command and update beta. Update MyTallies.
Select a tally to update alpha or updated beta to 7.
Well, my watch is still showing alpha because I didn't update the selected watch tally. But if I go to the picker, I can see that beta has been updated to 7. Now, there is one problem that I mentioned at the outset that I can't fix, and that's when I tap on a widget to update, it won't be able to update the watch counter. And this is because it's happening in the background, and the iOS app actually doesn't get refreshed until we open the app. However, when we open the app from the widget, we can see the update is pushed through from the widget to the app and subsequently to the watch. And that's because there is a scene phase change and we are refreshing the entire array when that happens. So it gets transferred with the updates to the watch. Well, the final thing we need to do in this video then is to send updated payloads from the watch to the phone. So this means we'll need to create a send context function in the WatchConnectivity and a corresponding receive in the iOS connectivity. So let's start with the WatchConnectivity. So as I said, first we'll need to have a set context function that will accept the payload of a dictionary that's string any, where that may be any of our encoded watch tally, and send it off to the iOS connectivity class for decoding. Well, that's exactly the same as the one in iOS connectivity. So I'm just going to go there and copy it from there, and I'm going to use it in my WatchOS connectivity class. Below this function, then, I can create another function, though, that is very similar to the one that we created in the iOS connectivity for transferring the payload. So we'll call that function updateSelectedTally. That will receive an optional watch tally, so we can use the label selectedTally. Well, then we can use an iflet to unwrap it. And then we can determine the JSON data using an iflet to try, with an optional try, to use the JSON encoder to encode that unwrapped selected tally. If that's successful, then we can let the updated payload, that dictionary that's a string any, to be a dictionary where the string is update, where the key is update, and the value is that JSON data. And then we can call that set context to pass in that update payload. So on the watch, we'll have to send that every time we tap on our tally. So we'll need to go to that single tally view and update our action in the single tally view's tap gesture. But first we'll need to create an instance of our shared WatchOS class. And then we can use it to call the update selected tally function by passing in the tally manager's selected tally. Over on the iPhone, in the iOS connectivity class, we'll need a didReceive application context function here, just the same signature as we did in the WatchOS connectivity class. And that contains the payload as the application context. And we're going to be updating our UI here, so I need to create a task and make sure it's going to work on the main thread by using a main actor. Then we'll check to see by using an iflet that the updated tally is the application context for the key update typecast as data. If so, then we can use an iflet again to create the decoded tally by trying to use the JSON decoder to decode a watch tally type from that updated tally. Well, now we can create a container object by trying to get the model container for that tally type. Of course, this means we're going to require an import of Swift data. Now that that's imported, I can create a predicate for tally, and we'll find the one where the name matches the decoded update tally name. I can use that predicate then to create a descriptor, which is a tally fetch descriptor, using that predicate. And then I can get an array of found tallies by trying to issue the container's main context fetch function using that descriptor. Now there will only be one since our name is unique, but we'll need to use an iflet to get the first tally. And then we can set the tally value to the decoded update value. And then we can issue a save using the container's main context. And then we can update the widget center by using a shared instance reload all timelines function. And of course, this requires WidgetKit import. So let's test now. Again, back to the WatchOS first to run it. Once it's loaded, we switch to the iOS target and run the iOS MyTallies. When I tap on the WatchOS tally, it updates, but I don't see the update on the phone. However, if I switch on the phone to another tally and then come back again, I see that it actually was updated. Well, we ran into that issue with our widget as well, where we had to force a view to update with an ID change. So I'm going to stop both right now. And I'm going to return to the iOS connectivity class. And I'm going to create a new property here called ID that's initialized as a UUID instance. And then, after I reload all the timelines in our function, I can set the ID to a new ID. So I'll return to the tally selection view. And I'm going to create another onChange modifier. And that needs to watch for changes in the connectivity ID property. Remember, it's an observed class. Now, if it gets a change, you can set the ID property of the view to the connectivity ID property that had changed. And that's going to force a refresh of the view because it'll be different from the ID that was initially assigned to our view. So let's test again. Run first on the Watch app. I'll switch to the iPhone app now and run it. And now when I tap on either of the tallies, the update happens on the other side. You don't see the nice animation on the iOS side when it's being updated from the watch because of the screen reloading. But to be honest, you're not likely going to be having both the watch and the iPhone app open at the same time. And the other limitation is when you're at the home screen on the iPhone and you update the tally from the watch, the widget doesn't display the update. And again, that's because there is no WatchKit connectivity possible between the two. If you open the app, however, on the phone, you'll see that it is updated, and returning to the home screen, the widget gets updated as well. Similarly, if I update the widget, the watch version doesn't update either until you open the app. Then the payload is transferred and everything updates as normal. Well, that's it for this video, but I have one more for you in this series. In the final video, we'll add some app images and icons and create a watch complication that will not only serve as an application launcher, but also display the current selected tally value right on the watch home screen, where it will update each time the tally increases from either the watch or the phone. Now, if you've enjoyed this series, please give it a thumbs up and leave me a comment. Be sure to subscribe to my channel to get notifications of future videos as I release them. And you can also download my free channel listing app to be able to search for and find content from any one of my 350 Swift or SwiftUI related videos.